Cool. Hey everyone, my name is Dominic. I'm the co-founder here at Chromatic. We're really excited to share a this webinar with you. We brought in a fantastic guest for you today, Matt. I'll be introducing him later, but he's a staff software engineer at GitHub working on performance. So we're really going to dig into how you do performance for front end at the scale of GitHub. And GitHub, uh, we all know and love it. It's one of the like linchpins of the open source ecosystem. So yeah, I'm really excited, to be honest, to really investigate some of the tooling that makes GitHub work. And I use GitHub every day. So I'm going to share my screen, and then I'll jump directly into all of this. And again, don't hesitate to leave questions, comments, reactions in the chat. We always love that. Kyle is going to be looking through the comments, looking through the questions to raise them to us live and add your voice to the commentary and this presentation. It's supposed to be fun, everyone. Let's have a great time. Yeah, let's get into it. So the reason why we are all here is because fixing performance always starts too late. You know, as devs, we have like a front end seat, a front row seat to janky user experiences, right? But you know, it's only when users start complaining or your own team starts complaining that anything actually gets done. So we've all like if you've been around the industry as long as I have, you've probably you've heard this message of move fast and break things, and we've been almost like brainwashed by the gospel of moving fast and breaking things. But really, that kind of ends up as uh, like most teams practicing a slightly different gospel, which is ship fast and never really go back to optimize the thing. And like I'm realizing now actually that it's probably vibe coding in a nutshell. Um, so but like anyways, the first thing companies usually do when they realize that they have like performance issues is like they go and buy an application performance monitoring tool APM. So that would be Sentry, that would be New Relic. These are fantastic tools that are really powerful, right? And they help you quantify what the user is actually experiencing. Now I've done this myself. Like I've gone through all of this myself too. But the kind of challenge that you end up faced when you first get those measurements and get the performance score is that like you're debugging a live system with dozens of variables, dozens of ways that things can go wrong and things can get really slow. And all of these signals are blended together into the same trace. So you're left scrambling to discern what's actually wrong from a bunch of noisy signals. And often the root cause isn't your fault. Just because something appears on the front end, right? It appears to users, doesn't mean it's like the front end team's fault. It could be any part of the stack. It could be, you know, data hydration from a slow API, and your front end is like awaiting data to load, but like it can't do anything else until that data loads. So not really your fault, but it appears you know on your lap as a front end developer. So in other words, like you know the tip of the iceberg is really what your users experience, and all the layers that underneath are what you know we have as developers to debug. So we're starting to see sophisticated front-end teams instrument performance in a different way at the component level, in addition to their existing performance monitoring tools. And since front ends are assembled from components, isolating issues down to components actually helps you debug the source of the issue instead of trying to trace down and divine what's wrong from page level signals. And because components can actually be reused everywhere, fixing issues in components can actually improve your whole application's performance because those fixes get deployed across your entire application. So I'm Dominic, the co-founder of Chromatic, the company behind Storybook, and I'm joined here by Matt Costabile, who's the staff software engineer at GitHub, leading web platform. And his team is responsible for building the tools that enable us to introspect performance at the component level. They just open sourced their own performance add-on. Yeah, I want to hand the mic over just to Matt real quick. Matt, can you introduce yourself and say hi to the folks at home?
Yeah, hey, I'm Matt. I'm a staff engineer at GitHub. Like Dom said, I work on our web performance team right now. I've worked on and with our React platform and web platform teams, and then a bunch of product teams before that. So I've touched a ton of different things across GitHub. I've been there about 5 years now.
Look, I'm so excited to have you here just to learn a bit about what's going on behind the scenes of one of my favorite tools.
Yeah,
Component instrumentation focuses strictly on front-end behavior when rendered in a browser. And the difference is that it intentionally omits the other parts of the stack, like backend, network, or APIs, because there are other dedicated tools to monitor that stuff. Think about all the performance monitoring tools that we just showed. So really, we want to consider the front end in isolation, and in considering the front end in isolation, we are able to better pinpoint what's actually wrong. So when you have performance visibility at the component level, what we're also noticing is that, look, the engineering culture can change as well. Developers see performance cost while they're building. Teams can set performance standards for their components, and performance becomes a routine part of just doing the job of engineering. So that's not to say page level APM is bad. You end up needing both, and we'll see why. Page level monitoring reflects what users actually experience. So what are users feeling? Where's the app slow? Which flows are actually degrading? Whereas component level actually is really about targeting and identifying root cause issues really early in the dev loop, so you can fix them in the dev loop instead of getting reports from your production users roasting you for for not serving them the experience that they demand. Without further ado, I'm gonna hand the mic over to Matt, who's gonna walk through the ins and outs of how GitHub does front end performance. Matt, are you ready to go?
yeah, let's do it. Okay, just waiting for. All right, so I'll go through a case study first, and then we can talk a little bit about more what we're focusing on and why. So we've recently done a lot of work on the pull request page. So I built like a small version of some of the issues we saw there in Storybook here, and we can kind of just go through the initial state and then a few things that we noticed in this profiling tool, and then from there how we optimize some of those things away and what it looks like now, more or less. So I think one of the things Dom mentioned earlier was that component level performance monitoring helps you understand what's happening, find root causes, and fix them. But it also gives you a place to do that in isolation. So in a large pull request on .com, we have a ton of diffs. Some of them take a little while to load, so we'll stream diffs in over time. And it makes it really hard to get good, clean performance metrics until that's finished. So if you have something that's like streaming in 300 or 400 files, any of the metrics that you try to get while that's happening end up getting muddied out by other things on the page. And it gets really hard to just set up an environment where you can make small changes in that place and then see how they impact. But you can really easily do that in Storybook, especially at this component level, because you can take all that other stuff away. So here we have a very minimal version of a PR page. We've got some diffs with a pretty complicated DOM. I think this one has 30 or so files.
Gosh,
Some div.
we have a DOM diff in our application, and that component that does that. It's so hard to
Yeah,
actually make this performant, and we've tried, and so like I'm thrilled to see this. One of the it's like You know how tables can be one of the trickiest front-end components to actually make performant? Like there are whole companies dedicated to selling table components. This is like at that level of difficulty. Thousands of rows, thousands of characters, tens of thousands of characters. It's wild.
Yeah, and the small details that go around it too. So a lot of the interactions for like keyboard navigation across these things end up with tables underneath them because it gives you better semantics for navigating with a keyboard. Uh, we have hover effects on all of these things. So if you in .com for real, not here, but when you want to add a comment, it's a hover that tracks your cursor around, gets added there. There's the like menus for talking about things with Copilot as well. So like the amount of DOM that generates is pretty enormous. We can actually see like for this small example with 30 or so items, we have DOM counts. Now to remember where they are.
Yeah.
There's a lot of stuff in here still, but we do have DOM counts somewhere, and I can find it in a little bit. But yeah, here we go. DOM nodes. So those should update over time. So if we do like a refresh here, we'll get this one
Whoa.
having 2,700 DOM nodes. Our larger stress test has 28,000 DOM nodes, and that grows pretty crazy over time. It's just like quite enormous on anything large. And lots of things work at the component level when you have a small amount of DOM in them, and totally get destroyed when you have something really big. So the interaction that we built this around when we were starting to fix something was this panel that resizes, and you can like drag it. So we had one that with 2,700 items doesn't really work very well. If you have one file in there or just a bit of text, it works fine. I didn't have a smaller example here, but like as you start dragging this around, we can kind of expand the frame per second. We have frame time, a little bit more frame timing information, main thread blocks. So we'll see the long tasks kind of grow here. Total blocking time is going to go up as we drag that. This is built in React, so we also have React performance profiling set up, and we get update time for all of our updates and segment those. So like, as we start dragging this thing around, we'll just watch the frame per second drops pretty substantially. Also, like it doesn't track your mouse at all. It jumps around. It's like never in the right spot. And all of
Gosh.
them just start going red really, really fast. I think I've got a pretty sizable computer, so I'm also just going to drop the CPU throttling 4x as well, and we'll see that again, where now it won't move at all, or almost won't. Frame per second is dropping down to like 10. We're basically blocking the thread all the time here.
So I'm on an older MacBook, and this is what I get. I can actually see that. Yeah.
Right. And I think someone asked in the chat if there's going to be a link. They're on all the examples here are on the Storybook add-on performance panel repo. We could share that out later if it's the link to those. So you can see the examples and run them yourself too.
Yep.
Already
Louis
done
pasted
that.
it in the comment.
Cool. Thank you.
Thanks, Louis.
And so I can go over like what was happening there as well. So I've got write-ups in there too if you want to read them through for what was happening too. But the big areas here were we have this situation where someone puts a pointer down and they start tracking the element. And we have this pointer move handler that was taking where the pin width used to be, getting a max of that in a diff of the movement of the mouse and setting it again. So they were basically thrashing that entirely on every update because they're subscribing to the state that they're updating.
Hmm.
They're also had it wrapped in a callback, so they're reevaluating that as well and getting a new object for that every time, a new function. That was the dependency of an effect. So this was also setting up event listeners and tearing them down nonstop. So as you were dragging every time React committed, you're tearing down all the listeners, putting them back up, tracking state again, just like tearing down the thread up entirely, getting to a point where you kind of lock up React and you lock up the DOM both.
Because the
So,
browser's trying to process all of this, like, while also doing other things, right?
yeah, exactly. And you end up blocking all the other stuff from happening too. So on a
And it's
page,
one thread in the browser.
what was that?
It's single threaded, like the
Exactly. So yeah, the main thread is blocked there. We're also on those pages streaming content in. So while we're blocking that, we're not able to update anything else. So all of the all the network requests are getting stuck waiting for an opportunity to go and get painted. Uh, Everything kind of gets destroyed there. So it's a relatively simple interaction that just causes a lot of headache. If you go to like a bigger DOM, so we have that was at 2,700 elements, give or take. This is 10,000 elements, and it's
You can't even move it.
right. You can move a little bit, and then you just sit for a while, and it eventually shows up. Uh, it might even freeze a tab for a bit. I have one heavier test case, but it won't do anything, so it's not worth jumping into that one yet. But then we go on to the first set of improvements, which is, I think, pretty common for anyone doing React work. If you have anything that has a lot of very, very fast, frequent updates, you typically want to sidestep React and start getting outside of that. So instead of setting the pane width on every move is React state, we started tracking that as a inline style. So you just rewriting the width over time. And then when you stop dragging, you update state once and you get rid of all of the kind of the thrash of having to subscribe to the state that you're washing and updating that thing continuously. So here we're getting the width based on another value in the DOM, but it's looking at how big the container is every time, no longer relying on the current pane width to do that. And we end up with only one set of listeners that get stood up and torn down once on mount when dragging changes instead of on every pixel change. And it like
Right.
starts getting a little better. It's still, we're still tanking frame per second on that. Frame time goes way down. We also see on the React side slow updates. Number down here is probably too small for people to see easily, but we track slow updates as well. So this is anytime React updates and that update takes a certain amount of time. I think it's anything over one frame. So if React has to wait to paint, we'll track that here. And it'll follow the mouse a lot better, but it's just really slow.
Yeah. And is that also represented in that P95 duration?
Yes. Yeah. Yeah. So the P95 duration here is going to be uh, just a percentile of all the different updates you had. So you have a metric you can look at over time. So
Yeah.
if you have one bad update and many that are fine, we want to make sure that you keep that tracked and you can see that and know that there's still something there to fix, even if your average update is relatively fine.
Got it. And tell me about the jitter and the layout stability stuff that you're working on because it's really present in the end user experience of you trying to drag that thing around. And how does that get reflected in layout stability or is that panel
Yep.
like what I think it is?
Yeah, so that panel will track like CLS, which here is not so important, but style rights. So this is like one of the small things that are a little hacky in how we're tracking. Most of the metrics here are tracked using performance timing, element timing, and those kinds of things,
Hmm.
where you have a browser-based observer wherever they're possible. There aren't any for style rights, so we do just we patch uh, set property and style
Yeah, yeah.
track whenever they're
Uh,
changing.
you
And
know, um,
quick jitter will catch when that happens and then paint fails to happen within a certain amount of time. So we can say uh, something should have painted and isn't painting. So we're blocking style updates somewhere.
yep. There's uh like how does this get affected? I guess how does like examining this stuff affect the the performance that you see because sometimes like instrumentation of say tests and it like ends up actually affecting what like it ends up differing from end user experience.
Mhm.
Is that present here too? Like just like analyzing and setting watching all of this stuff ends up affecting the performance of what's inside that iframe.
It does a little bit, but it's stable.
Yeah,
So as long as you have a metric that you see in the beginning, you can compare it to what your changes are.
right.
And so there's like a little bit of cost from like JavaScript is single threaded. Uh, all the events are happening on the in the iframe preview. we're just kind of emitting stuff. And in the wrapper, we have listeners that are catching those events and handling as much of the data munging and cleanup there. So we're trying
Mhm.
to minimize that a lot. We're heavily memoizing state updates that are happening here, uh, trying to avoid as much of that cost as we can. It's not
Yep.
possible to get rid of it entirely unless you have a separate thread moving somewhere. So I think we could potentially do something where we get rid of it entirely, but the cost is high and the value is low compared to just having a stable baseline.
Right, right. I mean, it's the same challenge of any kind of instrumentation tool, like any test instrumentation.
Yeah, but for most of these things, they're using performance observers from the
Hmm.
browser and they're getting relatively cheap access to a lot of those values. And most of the transforms are just P95 evaluation, tracking maybe 10, 15 versions of a value over time. So they're relatively cheap overall. Yeah, it's always a problem.
Can I interrupt with a couple questions that have come through? So one is, I think based on your README, that this works with any renderer. It's just if you're using React, you also get some React profile kind of stuff.
Yes, I
Was
believe
wondering if
that.
you could speak to that.
Yeah, I haven't tried it in all of them.
Okay.
I've done it in a plain HTML renderer, so
Okay.
we can check out the docs too over here. And this is just a plain universal HTML only renderer, and that works fine. The only thing it loses is the one React panel.
Yeah.
The React DevTools panel exists only to support the React profiler.
Yeah.
Uh, I think there is a good opportunity for other tools that have similar profiling tools. I don't know them that well, so
Hmm.
I have less knowledge of if Vue has a similar primitive or solid or any of those. But I think we can
Okay.
extend it to fit the same kind of model and have panels that swap in and out for the specific frameworks.
That's a great idea.
And I'm happy to take PRs to add it.
Hmm.
We use React internally a lot, so that's kind of what we built to support. And
Sure.
then I think if one of the engineers at Adobe saw it, I think from Dom's post on LinkedIn or something. It was like, hey, I want to be able to do this with a Spectrum web components. How do we do that? And I think we had a working example for them in like a couple days. So, happy to take it's
Yes,
super easy
that's
to
incredible.
use.
Yes, submit
Um,
PRs and that I love that story. It's the magic of open source.
Yeah.
yeah, for sure.
You have a use case and you need some other stuff there. Like let's build it and make it work for everybody.
Hmm. One other theme of the questions is around testing this stuff. So like what you're looking at is like live, you have to navigate to the story and play with it yourself. Is there a way to do this in a testing environment, whether that's integrating with the component tests that Storybook offers or running them in CI or anything like that?
Not yet. I
Okay.
don't know yet whether it's easy to access the data from the performance panel in a storybook test. I think it's not directly, but I could be very wrong there because it runs the test run, I believe, on the preview and not on the built panel too. But all the data is admitted from the
Hmm.
preview, so we just could build a similar type of listening tool that the panel uses,
Yeah.
designed to be relatively transferable, so it could go anywhere.
Okay.
Most of the metrics here are the same kinds that you probably are using to monitor your app in production anyway. So your web
Yeah,
vitals on listeners, those kinds of things are all there all the time.
Hmm.
And I think we could be in a place where we start emitting a baseline value, storing that, and then have tests that compare against the baselines you set and make sure you don't go
yeah.
above or below a value.
Yeah.
Uh,
Yeah.
we've done,
Alan Smith in the comments just wrote that like it'd be cool if to record and track regressions over time. So basically exactly what you're saying, Matt. Like
Hmm.
emit the baseline, store the baseline somewhere, even locally, and
Yeah.
then have like a Storybooks test runner um, like do that comparison. And it's
yeah, I think there's a huge fit there. I think it
yeah,
also the same kinds of things would be really good with AI tools at some point because you set your baselines, you emit
yeah,
metrics, you tell it how to listen to those metrics,
Yes,
and what they need to optimize, what they need to not regress on,
Yeah.
that kind of stuff. I think it'd make
totally.
really cool regression tests at some point.
Yeah. I mean,
Yep.
all of these data would be fantastic in an AI use case, just like it is in a human use case. Like they're looking at this stuff as well.
Yeah, exactly. And like the first step is always, no matter what you're doing, is, or I guess maybe it's not the first one. The first one is like build a product and make it work a little bit.
Yeah.
And you're at the point of trying to make it better.
Yeah.
You can't say anything is better unless you have an old comparison to do, like, to compare against. So you need metrics to say that you're improving. It's So as long as we start building the metrics first, collecting them, then build the tools that read them and understand them and help to improve them and make sure we don't go backwards anywhere over time. It's
You know,
really valuable.
It, yeah, and just to add to that, like it occurs to me that's not only valuable for the individual developer, in your seat, but also like the folks doing the prioritization around performance. Like everyone wants to see that the number goes like the number is going down, at least in the case of like FPS or rather performance, right? Like your performance score actually, or I don't whatever way it goes, like the good way. They want to see the
Honestly, green
delta.
boxes, right? Like
Yeah. Up
whatever
and to the
gray
right
green.
or down and to the left. I don't know.
And it's really valuable to be able to show too, because
Yeah.
I think it's often easy to have performance work get deprioritized because it's very hard to show improvements over time. And many small improvements add up. Like very rarely are applications and sites slow because one problem exists.
Yep.
Like the collection of 150 problems, each of which has a very small impact, and then together it's really, really valuable cumulatively. I think we had a problem a couple years ago where there was something in like one of our base components. I think it was like a button,
Yeah.
and at the scale of I also made even a PR page. It's like at the scale of a PR page where you may have 40,000 buttons that could render at a time. Uh, Even if they aren't rendering, there's like a small incremental cost of a lot of the things happening.
Yeah.
And like shaving 10 mil off something that happens 40,000 times is extremely valuable. And
Right.
shaving 10 mil off something that doesn't happen often is not as valuable. So like how do you track those things and show that these little small impacts add up over time and on any complex page?
Which is where the component model, like thinking about performance from the component app is so powerful, right? Because, if you're just looking at that button component, yeah, 10 milliseconds like off doesn't really mean anything at the level of just that one component in isolation. It's when you have thousands of DOM nodes with that component. That's when yeah, the performance impact it does add up.
Yeah, definitely. And it shows like really well. And it's kind of neat that Storybook gives you a great place to build complicated DOMs as test examples. So
Yeah.
like, these are
Yeah,
things
let's
that
go through them. Sorry, like we're like
nope, different.
just hanging out here.
The kind of thing where you can build a sample of the complexity that you see in production, strip away all the other stuff. You get rid of all
Yeah.
the network requests. You get rid of all the things owned by other teams on a page that may interact, uh,
Mhm.
and you strip down to just the baseline. How fast can this be? And is this something I need to optimize, or is the problem somewhere else?
Yep. Well, and that's what's going on with this on the left-hand side and the sidebar, right? You have one, two, three, and four, and it's a bunch of different ways that you've optimized the performance using the same stories, just different implementations. Is that
Yeah,
right?
and they were all like very, very tiny differences between them. So yeah, we can jump to the next one now because I think
Yeah,
that covers
let's do
most of
it.
that. Uh, this one comes and uses the same techniques, uh, add some CSS containment, and that kind of stuff. Or this one doesn't. Sorry, this one doesn't yet add the containment, but it does a little bit more optimization on the drags, so they're a tiny bit faster. So we get relatively instant use on. We're still, by the way, throttled to 4 down.
Yep.
So this is like the small story with 30 items.
I
Pretty
mean,
good overall.
this is already a night and day
Yeah,
performance,
and we can
like
go back and
improvement. I remember default. Yeah.
a little bit sometimes. So like it's not the
Yeah.
screen, it's the input just doesn't ever register well. Then we go to the one without CSS containment, and we stay pretty close to like 30 frames per second, which isn't too bad for the 4x throttle and zoom sharing with 4 tabs open. Like that seems okay.
Yeah, yeah. I
And we
mean,
go to
I
like
love
the heavy
the FPS
versions
stuff.
too, where like we've got the stress test story in each of them, which is 300 files. The nav has 18 sections in it. They
How
don't
many
do.
DOM nodes are in this one?
Yeah, let's check. This one's 28,000.
Oh, geez. Okay, so what was it? It was the default had like 2,000, the heavy had around 9,000, and this stress has like 28,000. Is that right?
Yeah, and I think those start getting close to what we see on large PRs. I think we may even go 3 to 5 times this on some PRs currently. So they get very heavy, and these interactions add up a lot to the point where the JavaScript stops being the cost, and it's like how fast can the browser paint this thing? Uh,
Yeah.
are your styles optimized? Do you have
Yeah.
selectors that do a lot of deep comparisons?
Yeah.
So I think while we were building this, and the page layout component that we're working on here is a bare copy of the one in Primer React. So like the
Hmm.
PRs that optimize this component are in Primer. They're also linked from this here too, so like people can check those out and see those are like the actual code changes that happened in production. At this point, we ran into a problem where the JavaScript was entirely fine, but we had a has selector in CSS that was doing a really deep comparison, and then
Oh,
it
golly.
has something with a star after it. So it ended up like locking up all of the thread anyway, but it was the browser trying to paint rather than JavaScript being the problem.
Hmm.
So you get these really
Those like
interesting
those
cases.
Yeah.
selectors can be so feel so innocuous when you like add them.
Yeah,
The more generic ones, but yeah, I guess that when you have 28,000 things to compare to, um, they they are very taxing.
yeah, and it's a really interesting thing to see because it's the last thing you think to optimize, and the costs can really add up, but they hide so well. And even finding which ones are troublesome can be difficult.
And I mean, imagine if you had to do that in Sentry or like a New Relic. It would be impossible because you'd be, off on a fishing expedition fixing everything but the CSS because
Yeah,
it can kind of escape you.
yeah. I think the only thing you see go bad there in most of your metrics, like INP attribution, it'll be like paint timing, which
Yeah.
is also React rendering timing. So it's like,
Yeah.
is it React rendering slowly? Is something blocking the thread unrelated? Uh, styles like it can be really difficult to track down, especially if you're at any kind of environment where you've got lots of stuff happening. And that's
Yeah.
where the component level testing really helps out because you can get rid of everything else and be like, okay, I've got DOM that's relatively inert. I've got the same thing happening in 3 different kinds of stories. This one's slow. What are the differences here?
Hmm.
And really isolate a lot of that stuff. So yeah, now in this one without containment. So this is just optimized handlers. Uh, we don't add CSS containment yet, but this is the 28,000 node story, and we can like actually drag it, and it follows the mouse pretty well.
Yeah. A
If we
far
drop
cry from the previous examples.
right, if we go back and we stop throttling, like it's better than any of the previous examples, including the smallest initial case.
Yeah.
And then we end up with the optimization side. So the last optimization, where did I throw that PR? So yeah, the last set of optimizations there were doing a little bit of coalescing of changes. So as you move the mouse, you get more updates than the browser can paint over time. So you really need only one state update per animation frame.
Right.
So we end up tracking with a request animation frame so
Mhm.
that as we track
Right,
the
right,
mouse,
right.
we're only getting one state update at the last pixel. We're adding this second attribute onto the pane, which is the navigation and the content area that has this data contained. Now we can go into the styles, but Data contain is just going to contain strict and add content visibility. So we'll stop painting off screen content and contain layout and style recalculations to the individual panes. So they stop getting evaluated everywhere. And then we come back in and we can just jump right to the biggest test, and we get basically
That's really not
the
bad.
amount of frame
Basically
per second.
30 frames per second, right?
Yeah. And that's with the 30,000 DOMs in the node situation.
Yeah.
So
Like that's the equivalent of movie frames per second, right? Like what you see in cinema, which is totally fine.
yeah.
Obviously, like if for a video game you want 60, but this is for 28,000 DOM nodes, that's pretty incredible.
And if you get to a place where you have a product that can virtualize content as well, like this is probably
Yeah.
not something you run into all the time. For PRs, we've started doing that on very large pull requests,
Oh,
but
tell me about that.
we try not to. So on a very, very large pull request, I forget what the metrics are now, but it's like our P95 size pull request. We'll
Hmm.
virtualize content so that we only paint a limited amount of nodes to the screen, because otherwise it just gets unmanageable.
Hmm.
Also, people are less likely to be reviewing them file by file in that case. So
Sure.
it's like less helpful to render everything all the time. And there's no need to stream a lot of the content, because if you there's files off the page that you never look at. Streaming it has costs, and we can avoid a lot of that stuff in the middle. But most of the time, we don't virtualize those. It's only on like the highest amount of content, and we try
Hmm.
not to, because we don't want to break any of the find and page features, any of that stuff. It's mostly a document, so we try to keep it as simple as possible.
Yep.
But
Alan Smith in the comments says, "I love this so much. It's really hard to see this stuff at a design system level," and describes a real use case around adjusting the performance of a tooltip, and it's kind of tough to see performance implications at the single component level. But he had a bunch of tooltips on thousands of elements, and that's where it started to degrade. So this type of stuff, yeah, I think it's fantastic for introspecting.
yeah, definitely, it's the best way to isolate problems and reproduce them simply. And
Yeah,
once you can isolate them and reproduce them, you can fix them. And then you have if you're trying to do this without a tool like this, like the standard
yeah.
way,
What's the alternative? Show us like the alternative,
the
the old
just
way.
like this, you throw a like page load, you'll do a refresh, you'll end up with a bunch of graphs, and then you have to go through different panels, which is where it gets a little complicated. So you might do a performance trace like this.
Yeah.
And I think this in Storybook is a good example of I've got a ton of events in here. I can see frames. It doesn't really matter what's going on up there anymore, but
Yeah.
here are all my updates happening. Uh, it's the entire page I'm getting here. So like,
Yep.
not saying that Storybook's slow, but like I have no idea which parts of the page are adding to the flame graphs unless I start really digging in to analyze them. Because I
Right.
can't see change over time here easily. I can like look at frames. I'm like, okay, this didn't render until there, so like I start tracking here.
I mean, even like you
And I
can,
zoom in.
show the story itself in its like its own iframe without the manager, but you're still experiencing this like these flame graphs, these traces that are can be pretty big. Um,
You
and
start
this is the
tracking.
UI that you have for all of that.
What do I? All right, man. If I'm like trying to get to a layout cost, it's like I got to find the
Yeah.
layout and go back to what thing might have triggered it, instead of
Right.
having a nice visual indication as I'm making changes, what's happening. I
Yeah.
We also track things like memory and pressure there. So like I can't do that from just having a performance profile. So like
Hmm.
we have live stats that I believe only works in Chrome, because most browsers don't support memory tracing. But Chrome does, and it's quite nice. So you end up with where's the see if I can find where yeah, there's a memory timing. Yeah, memory and rendering. Right. So we see live stats on what our heap looks like, GC pressure over time, so we can see how the garbage collector is working, the peak memory use. So how expensive this thing is at the worst case while I'm interacting.
Yeah.
Uh, I think that's really, really valuable for situations where you may have a lot of data transformations that happen in your renders. So if you did something where you've got like an array of stuff and you like map it 3 times, filter it, reduce that value to something else,
Yeah.
you'll see your peak memory grow because you're allocating all of these intermediate arrays. But you may not have heat that stays that high because only when those things are being evaluated. So you can see like, did this thing grow way higher than I expected? Maybe I need to go back and get rid of those intermediate arrays and focus on like single passes that handle all the transformations together.
Oh,
So like to do that,
what's
otherwise you end up having to come start a profile, record that, then
yeah.
go
I
back,
mean,
do
what seems notable to me is like what this performance add-on gives is a real-time observability for things that are rendering in the browser. And I think the alternative is having a bunch of profiles, like snapshots of a thing that you then go and introspect at a later time. And for the cases where you want to get some um, directional feedback on did this change work or not, without having to go run through that entire profiling, waiting, um, checking, then doing it over and over again. This is like so much faster.
yeah. Yeah, it
Yeah.
gives you like a nice, it shows you immediately what's happening. It's like a nice head-up display. You can see all of the things you need to look at in one glance.
Yep.
And if any of them looks problematic, you can try to focus on it specifically. So maybe you do need to go take memory profiles and see where those costs come from. Like we're not
Hmm.
doing any deep memory profiling and there's not good APIs for doing that, but then you know, okay, I need to go do this again, make a real profile, figure out what the
Yeah.
problem, and you can ignore the stuff that doesn't require it.
In some ways, like what you're saying is there are boundaries for for each tool. There are correct use cases. So you have that real-time performance observability. You have the profiling. You also have APM, like classical like application performance monitoring, and each one has a different story, and they all kind of need to fit together in order to do the job of performance analysis and debugging.
Yeah, this gives you a chance to find problems when you're developing and then catch them later, build regressions around them, and evaluate them over time.
Yeah.
Production profiling is great for did users run into a problem? How did these shift over time? Where you're looking at long time frames,
Hmm.
especially important for things like INP. If you're deploying a lot, your changes in INP are going to be very hard to follow on any single deployment
Hmm.
because you have clients that never get updated. So you have interactions across all of your deployments that interact with each other, and you're looking at
Yep.
these like long-term trends. So you can see around when things get worse, and you can like narrow in those in, and this gives you a place to go. Say, I know these things changed at this time.
Yeah.
How do I recreate those problems and figure out where it is on the small scale? Usually, you end up starting with that bigger picture of okay, I have a problem. How do I fix it? And this is more how do I avoid running into those problems first and make sure I don't run into them a second time if I've already run into them once.
Hmm. Hmm.
Mhm. Yeah.
I think
Going
that
back to the memory and rendering panel, I'm curious if that works similar to the React profile one, where if you're just using a different browser other than Chrome, does that panel just not appear? Or
I
cool.
think it may appear and it may just say this only works in Chrome. Offhand, I don't
Yeah,
know.
sure. Sure.
Uh,
And then Alan with another great question. He's wondering if you found a significant difference in performance metrics based on what browser is being used. So Safari, Chrome, Firefox, etc.
I haven't actually compared them that much across each other
Okay.
for the tools, so I don't have a good answer. I know we track many fewer things outside of Chrome just because they don't have the APIs everywhere.
Yeah.
I
Yeah.
forget what they are offhand. They're in the docs for what is supported. I think element timing is only supported in Chrome as well. Memory. I try to remember what else, but I think those are the two that are most notable.
Okay. Gotcha.
And then element timing is only supported on text nodes and image nodes, even in Chrome.
Okay.
So it's you don't get numbers for everything just because it exists. It's only if it's tracked.
Uh,
Let's zoom out on the impact that this performance add-on has had and where you kind of see it going in your both in your organization at GitHub um in open source too.
Yeah, I think performance monitoring and improving performance at GitHub has been a real push, especially over the last 3 months. But it's always kind of been an important thing that we focus on. I think at different times to different effects, because like you run the line of like building new things, making them work really well, making them as fast as possible, and you're always at different stages of that depending on where the product is. Even for mature products like GitHub, because we're adding a ton of new features all the time, and sometimes it's like build a thing, make it work.
Yeah.
And once we have things working and we can start improving them and analyzing them, it gets a lot easier when you have tools that make it easy to do that. I think
Hmm.
we
Hmm.
any large company has a lot of people working on a lot of different products, sometimes in their specialty, sometimes without,
Yeah.
and they may not be aware of all the different tools they have access to debug problems or to build and avoid those problems to begin with. So making them easy to surface everywhere is
Yeah.
really important at that kind of scale.
Are you
Uh,
finding that this performance add-on is sorry, go ahead.
it's a good training tool because people
Hmm.
see marks that look bad, they see red danger colors, and they're like, "Oh, how do I make this better?" So
Yeah.
it gives you an opportunity to work with junior engineers and people less skilled in the area and show like, "Oh, these are the kinds of ways you can make this number better over time." And becomes a real nice kind of a tool for training, understanding problems, and teaching and learning.
Totally.
I was
And
curious
it
about that. So I noticed it seemed to be designed with an educational aspect to it, like the way that there's all those tooltips explaining what things are. And
yeah.
I just thought that was really well done. And I was wondering if that was a goal of the project was to help educate.
Yeah, I mean, honestly, like I look at these kinds of numbers all the time, and sometimes I forget what they mean. There's a lot of acronyms.
There are a lot of acronyms.
Like I'll be
Yeah.
honest, there's like they change all the time. So
Yes.
Google especially has like web vitals that they pushed in Crux. Uh,
Yeah.
those metrics are fantastic, and the ones that we decide are important change a little bit over time. So you like first
Yeah.
input delay, which people stopped caring about as much compared to IMP, which is interaction next paint.
Right.
And like there's just so many three-letter combinations and four-letter combinations that some have a good fast way to find the answer. A few of them are heuristics based, so it's like I think it was frame stability is pretty explanatory, but what was the one you pointed out earlier where it was maybe jitter, where it's based on whether an update happens within a frame,
Yeah.
and like
Okay.
that's not really a term I think that is codified anywhere. So being able to look at it and say, is this metric one that has a raw number that I trust entirely, or is it one where maybe there's some room on the side because it's being calculated somehow and maybe the calculation isn't perfect yet?
Yeah.
And so
I don't
it
think
sounds like
jank is defined either, but everybody knows what that is.
yeah, maybe we need a jank score. Just like summarize all that stuff into
Yeah. Someone had a fun question, wondering if your add-on was used while you developed the add-on.
It was not directly, but so and in PRs in Primer React, there are many for page layout between like November, December, and mid January. A few of them have other versions of this in them.
Yeah.
They'll be in commit history somewhere and probably not, like, never landed there.
Yeah.
The first version that was building it was like, what if it was just a widget that floated on the screen? But it ended up floating in the storybook panel.
Yeah.
Yeah.
I didn't
Yeah.
keep the panel in storybook instead of in the preview, because in the preview it also adds costs when you're running other tests too. It
Yes.
gets
Yep.
in the way of your visual regression testing and that
Hmm.
kind of
Hmm.
stuff. So then you're like, okay, I have to turn this stuff off in this case, but not this case, which just like muddies a lot of that tracking.
Yeah.
And
Yeah.
it'd be just like, well, why are we building this thing that we put everywhere instead of in the place where we're doing the development anyway?
Yeah. And question for like, you talked about Primer. It sounds like Primer is like the first place where this add-on is deployed. Um, does GitHub have more storybooks where you're pushing this add-on out to? And how is that, if so, is that like impacting how other front-end engineers in the organization think about performance?
Yeah, we've got two main places where front end development is happening for GitHub.com. So we have Primer, which is the design system. That's our component library and tooling, CSS standards, all of that kind of stuff.
Hmm.
Then we have a monorepo of UI packages, where we have a second storybook that takes a lot of the Primer things and wraps them up into bigger components, more page layouts, setting pages, and those kinds of
Hmm.
things that are really standard designs. So I think more like in the old like atomic model, like Primer are the building blocks, and then we have this other set of components somewhere that put those blocks together into reusable pieces that we share more broad.
Yeah.
And we've also deployed this in there. So we started building it in
It
Primer, moved it over into that other monorepo, deployed it in both places, and then open sourced it after that.
Right. And talk about like the people impact on this. Like, you're one person leading this project, or leading the kind of development of the add-on. As you've seen it roll out to people and seen your colleagues at GitHub and the folks at large on the internet respond to it, like, you know, how are you, I guess, yeah, what have you seen in terms of response internally and externally?
Yeah, I think it internally has been really, really great for helping people notice problems that they might not
Yeah.
see otherwise. Especially for like you have this page and you have a ton of interactions. We have a lot of users with very different size machines,
Yeah.
and you tend to not see those small changes over time, even in your monitoring, your run metrics, because a slow interaction might not move the numbers that high, especially if you're looking at P50 or P75. You might start seeing them at P95,
Hmm.
and we can start seeing a lot of those numbers easily if you do like a 6x throttle and you build a story that's big and you can see the
Yeah.
graphs moving. And I think that just like shifts the mindset a little from I think about performance after someone complains to look at it at least building and see what I can make better.
I'm guilty. Gosh.
Everybody, right? It's the thing
Yeah.
like you got to make it work.
Yep.
And if the best problem you have is people telling you it's slow because they're already using it. So like
Hmm.
it's validated the product. So you need that first. Because if you spend all your time building a performant thing that no one uses, you don't get paid, and that's a problem. So
Totally,
Yeah.
totally.
how do you
And
how do you make it better and make people happy? And it's like a great feedback loop because not often do they say like, "Hey, this feels great," but the complaints trail off and usage goes
Mhm.
up, and like that's an excellent thing to start watching. Like as you
Mhm.
yeah.
get out of your user's way, like it feels great, and it's great to see that like lack of complaining. But
Yeah,
also like
absolutely.
we use this every day everywhere. So like
Hmm.
as a person at GitHub, like you're in GitHub all the time. Like
Mhm.
it's nothing but issues and PRs, discussions, and if it's slow there, it's just like it holds all of us up too. So it's like this
Yeah.
really nice feedback loop of it starts feeling better for everybody all the time.
Can you tell us a little bit about it sounds like the approach to building a performance culture for your front end discipline at GitHub, and can you tell me how these types of tools, this stuff like fits into maybe a broader kind of picture on um, changing the culture?
Yeah, I think so. A long time history, and like anybody that's worked at GitHub will tell you that there's like a statement that's been around is like everybody's on the security team. It's like the old CISO and head of security were had this thing. Anytime they went to a meeting, they're like, raise your hand if you're on the security team, and everyone has to do it. I think it's the same kind of thing. Is like everybody that's a developer is on the performance team. It can't be a group of people that go in and make things fast because the surface area is way too big.
Right, right.
and nobody knows a product more than the people who build it. So it's like, how do you tell people what's happening in as close to real time as possible? So they're like, you've got this kind of tool for when you're building the product.
Hmm.
You've got APM run metrics for when it's in production. We have an internal system for scorecards where we take web vitals and some other metrics, and we give different product owners internally scores based on that. So uh, it's like, do they have an INP that is at green level? So we,
Yeah.
I think there's green, red, and yellow. It's like things are good, you can ignore it. Yellow is like you should start looking at this, and red is a failing score that they have an SLO internally for how long they have to go and improve it.
Right,
And
right.
you start getting issue pings on that happening nonstop if you don't go fix them after.
So
So
that
it's a little bit,
those are the sticks, and what you just showed us today is the carrot.
this is the tool to make it so you don't have to get the stick, right? So
Yeah.
Sure.
it
Yeah.
helps you get to a place where it's always green, and then we can start making the high levels lower. Because at some point, when things are working well enough, you can start saying, well, red used to be 200 milliseconds, but everything's at 70 milliseconds. So why is
Mm,
200 bad?
Yeah.
mm,
At that point, if we go up 20% from here, that should be bad. And then
yeah.
you
Right.
start just like lowering the bar a little
Yeah.
over time and end up with a
Wow.
better
What a
product
metric for
that works really
success.
well. Yeah, so it's a nice like feedback loop. You have this on all sides. So it's like I can build something that I know is fast. I get notified when things slow down, and I've got this like scorecard that will annoy me until I fix it. And like
Oh,
those are some aspects I think we're working on some better synthetic tests too that give better long-term metrics in a more benchmark environment. Like
yeah.
bench tests for these things are always really tough because the bench can say great things or terrible things, and your users might have very different experiences in that. But it
Yep.
gives you a place where you can compare from and see how things change over time in a relatively stable environment, which
Hmm.
is really hard with any user metrics. So I think one we have where we're always looking at interesting spots is like usage for a product like GitHub on weekends is significantly different than during the week.
Mhm.
And so like we were working on some monitors, and like there's a one that started flapping on weekends, and it's like, okay, this interaction set is slowing down, but it's only slow on Saturday and Sunday, and the rest of the week it's fine. And then it turns out like mobile usage is 7 to 8% of usage entirely, Saturday and Sunday, but it's like 1.5% Monday to Friday.
Right.
Golly.
Okay,
Yeah.
this is like you see
Yeah.
those trends once you get to a place where things are relatively stable and you have
Mhm.
good metrics, because then you can start segmenting them really well and find where problem areas lie. So it's like, okay, is it a specific types of users having problems, specific surfaces, things using specific components, and just kind of rounding out a lot of the options there for tracking and monitoring.
Hmm. And it sounds like based on the comments, regression testing of some of the performance metrics in the add-on could also be pretty useful.
Yeah, definitely. Yeah, it's where I'd like to focus more as we have more time to work on it, because I think
Yeah.
that's the benchmarking set, regression testing, automated anything there will be
Yeah.
additively valuable.
And we'd love to work with you at
Yeah.
Storybook and
Let,
on
let us know if you need help integrating that.
yeah.
Like this is the first time I've built an add-on in Storybook, so it's been a fun experience. It's like a really like approachable thing.
Yeah. I mean, you stuck the landing, Matt.
Yeah.
It looks like we're a little bit over time, and I think we should wrap this up. Matt, thank you so much for joining the conversation, presenting a lot of the work that you're doing at GitHub. It's really impressive and inspiring for us all to see that work. Uh, do you have any parting thoughts, Matt? Ways that the community can find you? Um,
Yes, yeah. Thank you both. It's been really fun, and it's been great getting to know you doing this. Like Dom and I first talked earlier this week as like a lead up to this, and I think we only connected because of a LinkedIn message or something. So It's like a really neat way to get in touch with people around and experience the community a bit from that, and work
Yeah,
closely with y'all. Uh, the the repo's open source. The link was shared in the chat. Feel free to ask any questions there. File issues if things aren't working or could be improved. Open PRs if you have features that you want. Whatever makes sense. Like, please, it's open source for a reason. So like, let's make it as good as we can for everybody.
totally. Where can people find you online or follow the GitHub, engineering organization?
Yeah, so I'm Matt Costa 7 on most of the social media things. I don't do much on them, so if you send me a message and I don't respond, it's because I didn't look at it and not because
I didn't respond intentionally.
get a message from Dom in like my +2 at GitHub, and I only knew that because 2 days later he slacked me and he's like, "Hey, you didn't read your message, did you?" I was like, "Nope, not at all." So that I GitHub as an engineering blog, which I think is growing a little bit more too, and
Mhm.
uh, on Twitter and all the social media, GitHub is pretty active.
Yeah,
So I think those are great places.
Well, thanks for joining us and being so generous with the add-on and explaining it and sharing your experiences. This has been great.
Yeah, thank you very much. It's been really fun.
And thank you,
fantastic.
everybody else, for joining us. Thanks for your great questions and fun in the chat. Yeah,
All
take
right,
care.
later.
Take care. Here. See you next time.